Good morning. In this video I am going to complete problems 46 through 55 from the Algebra 1B Final Exam Review packet. Okay. On 46 and 47 we are to factor each of the following completely, and while you can use the ABC method on these problems, there's a much easier way to do it, and I'm going to do it that way. If you do the ABC method though, it'll work just fine. In the ABC method we did in the previous video on 44 and 45. So if you look at 46, what you have is you have x squared minus 81, and these are special type problems that you can solve by just taking the square root of each of the terms. So the square root of x squared is just x, because x times x equals x squared, and the square root of 81 is 9. 9 times 9 is equal to 81. So that gives you the terms, or the pieces that you're going to use in the final answer. So my answer is just going to be like this: x plus 9 and x minus 9. Okay? And you can always use the box method to double check your answer whenever you factor one of these to see if you get back to the original answer. So that would be the final answer: x plus 9, x minus 9. And again, the order doesn't matter. So if you wrote x minus 9 and then x plus 9, you'd be fine too. Okay? Same thing with 47. I'm just going to take the square root of 25x squared, which is 5x. 5 times 5 is 25. X times x is x squared. And the square root of 64 is 8. 8 times 8 is 64, so my answer is just going to be 5x plus 8 and 5x minus 8. Okay? This only works when you have something in the a squared term, or the x squared term, or the a value, and something is the c value. When b is 0, you can try to do this to shorten the process. Okay? Okay, moving on to 48 and 49. Here we're also going to use the ABC method to solve these. Okay? So I'm going to do 48 first. My a is equal to 1, my b is equal to negative 14, and my c is equal to 49. So in this case, I'm finding what times what equals 49, because that's my a times c, and what plus what equals my b, which is negative 14. Okay, well, 7 times 7 is 49. 7 plus 7 is positive 14, but if I reverse it and say negative 7 times negative 7, it's still positive 49. And negative 7 plus negative 14, negative 7 plus negative 7 is negative 14. So there's my answers. My a value is 1, so I have two fractions that look like this. This gives me the answer of x minus 7 times x minus 7. Okay? If you wrote x minus 7 and then put an exponent outside of it, squaring it instead, that would be fine as well. So for 49, I'm going to do the same exact thing. I'm going to do the ABC method. My a is 1, my b is 20, and my c is 100. So I'm going what times what equals a times c, which is 100. What plus what equals b, which is 20. It's actually fairly easy. 10 times 10 is 100. 10 plus 10 is 20. So those are going to be my numbers to use. And just like on the previous problem, I'm going to write them over my a value, which is 1. And my two answers are going to be really the same: x plus 10 times x plus 10. That's my answer. Okay? Again, if you're having trouble with these, we're running out of time, so you need to get help on this. Okay? Now, 50 and 51 are very similar to, or the 50 through 55 actually are very similar to the questions we just did, except there's a piece where we have to solve for it. So sometimes that means we're going to do an extra step after we do the factoring process. Okay? 50 and 51 are actually already factored for us, and all we're doing is applying what was called the zero product property. And the zero product property basically allows us to set each piece of the product individually equal to 0 and solve for x. And in most of these problems, we're going to get two answers. So I'm just going to set it like this. I'm going to set 2x minus 5 is equal to 0, and then x minus 1 is equal to 0. And I'm going to solve both problems individually, or both equations individually. So first I add 5 to each side. That gives me 2x is equal to 5. I then divide both sides by 2, and I get x is equal to 5 over 2. If you wrote 2.5, that's fine as well, or 2.5 as well. Okay. Then over here, it's just a one-step equation. I'm going to add 1 to each side, and I just get x is equal to 1. So my two answers for number 50 are 5 over 2 and x equals 1. 51, I'm going to do the same thing. I'm going to set both pieces separately equal to 0. So I'm going to say x minus 6 is equal to 0. And I'm going to say 3x plus 7 is equal to 0. So here I add 6 to each side. And I get x equals 6. And then here I'm going to get minus 7 minus 7. Leaves me with 3x is equal to negative 7. I divide by 3. You're going to get x is equal to negative 7 over 3. And it's fine to get a decimal or a fraction in these problems. So those are my two answers for number 51. Okay. 52, we have r squared plus 10r plus 9 equals 0. So the first thing I'm going to try to factor it using the ABC method. Now it's going to work in this process, but in some later problems it's not going to work, and we're going to have to use what's called the quadratic formula. Okay? Just to remind you, a is equal to 1, b is equal to 10, and c is equal to 9. So what times what equals a times c? Give me 9, and what plus 1 equals b, which is 10? Well, 9 times 1 is 9, and 9 plus 1 is 10, so that works there. We put both of those numbers over a, which in this case is 1, and those fractions are used to write our answer. So this is what we have at this point. X plus 9 and x plus 1 is equal to 0. So it's a little bit different because we still have the equal to 0. And now we apply what we did on the previous two problems to find the values for x. So I'm going to set them separately equal to 0. So I'm going to subtract 9 from each side. I get x is equal to negative 9. I'm going to subtract 1 from each side. And I get x is equal to negative 1. Okay? And those are my two answers for number 52. So again, on 52, when you have a ax squared plus bx plus c, a quadratic equation, equaling 0, you not only have to factor, but then you have to solve it. Okay? So let's look at 53. Same thing. First thing I try to do is solve it using the ABC method. This is what times what equals negative 7. What plus what equals 6. Well, if I have negative 7 times 1 is negative 7. Negative 7 plus 1 would be negative 6. So it has to be the other way around and say 7 times negative 1 is negative 7. 7 plus negative 1 is positive 6. And again, I put these over a, which in this case is still 1. So that gives me x plus 7. And x minus 1 is equal to 0. And again, just like the previous problem, I now have to solve them for 0, so I solve them separately for 0. X plus 7 equals 0, and x minus 1 is equal to 0. So we're going to subtract 7 from each side. I get x is equal to negative 7. Then I'm going to add 1 to each side, and I get x is equal to positive 1. Okay, and those are my answers for number 53. Okay, number 54 is going to be a little bit different. Okay, I would start out this process doing the same thing I just did. And I would say, well, I'm going to try to solve it using the ABC method. What times what equals 1 times 2, and then what plus what equals 7. The problem here you might recognize is that there are no two numbers that multiply to equal 2 that add to equal 7. The only numbers that multiply to equal 2 would be 2 and 1, or negative 2 and negative 1, and none of those add to equal 7. So the ABC does not work. Okay? When the ABC does not work, there are two options you can use. You can graph it in your calculator and try to find where it crosses the x-axis, because those are the solutions, or you can use what is called a quadratic formula. Actually, probably a quadratic equation would be a better name for it. But either way, here's a quadratic equation. You do not have to memorize it. It is provided for you on the exam. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. It looks complicated, okay, but it always works. And to get a, b, and c, just do the same thing you did before. So a would equal 1 here, b would equal 7, and c would equal 2. Now I'm just going to plug that in and solve. So I have negative b, so that's going to be negative 7, plus or minus. The reason this plus or minus is because these functions represent a parabola. And many parabolas go through the x-axis not once, but twice, like this example drawn here. And so the plus or minus allows us to get the two answers that you would need to find the two solutions. Okay, this would be one answer and this would be the other. Okay, so that's what's going to happen. And at the end, we're going to separate the plus or minus into two separate pieces. Okay, so back to the problem. We have negative 7 plus or minus the square root of b squared. It's important that you put that in parentheses, especially if it's a negative, because if you're using your calculator and you don't put a negative number in parentheses when you square it, you will get the wrong answer. Okay, calculator follows order of operations. Over 2a, which is 2 times 1, so you can now simplify it further. Negative 7 plus or minus. 7 squared is 49, minus 4 times 1 is 4, times 2 is 8. Over 2. Let's simplify it even further, so I have negative 7 plus or minus the square root of 41 over 2. And believe it or not, that is an acceptable answer. Because we don't know the square root of 41, I mean, we could put it in the calculator and get a decimal between 6 and 7. But because we don't know the square root of 41, mathematicians have no problem leaving it like this. This is the most exact answer. Okay? If I was going to write two answers out, you could do something like this and say negative 7 plus the square root of 41 over 2. And then negative 7 minus the square root of 41 over 2. That would be fine as well. Okay? You could put it in your calculator and get a decimal answer as well. That would get you full credit, but I'm going to leave it like this. So these are two possible ways of expressing the answer. Okay? In problems where you do know the square root, let's say it was square root of 49, which is 7, you would simplify it and have to work it out to get the simplified solution. I believe on the next one it actually does that. Okay, so let's do the last one on this video, number 55. Okay, now, there's a little trick here. Before you do anything else in this video, you have to get everything to one side. If you notice that every single problem on 50 through 54, it was x squared plus or minus something, x plus or minus a number equals 0. Okay, so it has to equal 0 before you can do anything else, before you can try the ABC method or use the quadratic equation. Okay? Here the ABC method is not going to work again, so I'm just going to jump into the quadratic equation. So it's going to be, again, negative b plus or minus b squared minus 4ac over 2a. And again, the quadratic formula or the quadratic equation, whatever you want to call it, is on the front of the exam review packet, so you can check, you can use it there. You don't have to look it up, and again, you don't have to memorize it. So here's a little bit tricky because my a is 1, my b is negative 5, and my c is going to be positive 1. Because of down here. Okay, so you're going to have negative and negative 5. And that's okay. When you simplify that, it actually is going to come as positive 5. Okay, and then I have negative 5 squared minus 4 times 1 times 1 again. So negative, oh, hold on, let me put over the 2a, 2 times 1. So negative negative 5 is positive 5 plus or minus. Negative 5 squared is positive 25 minus 4. So it is not going to work out very pretty, this one. So I was incorrect. I apologize. So that's going to be 5 plus or minus the square root of 21 over 2. And again, at that point, we can stop. We do not have to put it in. The square root of 21 is not a perfect number. Okay, it is not a perfect square, as they say. So that is fine. And you can also write the answers like this and say 5 plus the square root of 21 over 2, and then 5 minus the square root of 21 over 2. Okay? So those are the possible answers. And again, if you're having trouble with this, please come see me. This is the end of this video. Thank you.